In this video, I'm going to go through the word problems that were covered over equations and inequalities, just to give you a basis, some background for those of you who need some help. First of all, when you read through a word problem, make sure you read it through. And just like in ELA class, we need to read it a couple of times, you might need to read it a couple of times. That being said, usually the actual question is the last thing in the paragraph or whatever. So what we're actually looking for is the cost of a loaf of bread in 1902. Since that's what we're looking for, I'm going to call that X. So X is the cost of bread in 1902. Now we also have a cost of bread in 2006, so maybe I will call that Y. Okay, now that I have defined my variables, now what I'm going to do is I'm going to go through sentence by sentence and try to make each sentence into an expression or an equation. So it says in 1902, 44 loaves of bread cost the same amount as one loaf in 2006. Okay, so let's think about this. We have 44 loaves of bread that were 1902 bread that cost the same as one loaf of bread in 2006. So I just kind of went through bit by bit and made an equation. The next equation, or the next sentence, a loaf of bread in 2006, that's Y, costs $1.72 more than it did in 1902. So let's just kind of review our equations. 44 loaves of bread in 1902 cost the same as one loaf of bread in 2006. And in 2006, bread costs $1.72 more than it did in 1902. Now, since both of these are equal to Y, we can just set those two equations or expressions equal to each other. So we get 44x is equal to $1.72 plus x. I need to solve for x. So I'm going to subtract my x from both sides. So I subtract my x from both sides. I get 43x. I now need to divide by 43 to get rid of that 43 and get my variable by itself. And so I take $1.72 divided by 43 on my calculator, and I get 0.04. So that means that bread in 1902 cost 4 cents. All right, that's problem number 41. Let's go on to the next problem. In 2004, 3 wide receivers for the Indianapolis Colts caught a total of 37 touchdown passes. Reggie Wayne caught 2 more than Brandon Stokely. Marvin Harrison caught 2 more than Reggie Wayne. How many touchdown passes did each receiver catch? Okay, going with what I said a minute ago, the last part asks what we need to find, and we actually need to find all of them. Now, you can use any variables you want. In this case, because there's so many names and everything, I'm going to use W for Reggie Wayne. I'm going to use S for Brandon Stokely and H for Marvin Harrison. Now, you could use X, Y, whatever, but I'm just going to use this. That way they kind of match up a little bit easier for me in my head. Okay, so now I'm going to go to the first sentence. 3 wide receivers caught a total of 37 touchdown passes. That means 37 passes were caught by Reggie Wayne, Brandon Stokely, and Marvin Harrison. The next sentence says that Reggie Wayne caught 2 more than Brandon Stokely, and Marvin Harrison caught 3 more than Reggie Wayne. Now the last part is a part that some people didn't put together, and so this is the thing. Reggie Wayne is 2 plus S, so I can change this equation to 3 plus 2 plus S, right? Because W equals 2 plus S. Now I have everything broken down in terms of S. So I'm going to go back to my original equation. For W, I'm going to put in 2 plus S. Stokely is just S. Harrison is going to be 3 plus 2 plus S, or in other words, 5 plus S. Now, if I combine my like terms, I have 2 plus 5, that's 7. I have 1, 2, 3 S's. And so now I can just solve this. And I get S equals 10. That means that Stokely caught 10 passes that year. Reggie Wayne was 2 more than that, so he caught 12. And Brandon Harrison caught 3 more than Wayne, so he caught 3 more than this. That is 15. One last thing you could do to sort of check your answer is, do all these add up to 37? And yes, they do add up to 37. Okay, this next set is all from the inequalities, but I have to tell you, when I'm going to set them up, I'm going to set them up as equations and maybe put the inequality in later. I feel like that helps make sense of it sometimes. Okay, Pat is paid a salary of $500 a month plus a commission of 15% of the value of the jewelry she sells. Find the value of the jewelry Pat must sell in order to earn at least $2,000. The question is, find the value of the jewelry that she must sell. So I'm going to say X is the value of the jewelry that she must sell. Okay, now let's go to the equation. Pat is paid a salary of $500 a month plus a commission of 15% of the value of the jewelry she sells. Okay, remember that 15% is 0.15. And then this is like her base. She gets $500 no matter what. And then they add on 15% on top of that. Now, find the value of the jewelry that she must sell in order to earn at least $2,000. And this is what I'm saying. Right now, I'm going to say equals 2,000. Sometimes that's easier. And then later on, we can change it to a less than or a greater than. All right, so I'm going to subtract 500 from both sides. I get 1,500. I'm going to divide by 0.15. And so when I divide by 0.15, I get 10,000. So now is, like I said, this is when we can start making some sense of it. If we put it into words, that means she must sell at least $10,000 worth of jewelry to make at least $2,000. Remember, X was the value of the jewelry, so I knew that was dollars. That was the value. So she had to sell at least that much in order to make at least 2,000. And so if you wanted to rewrite, I think this answer is all you need here in words. But if you wanted to make it into an inequality, you would say that X has to be greater than or equal to 10,000 in order to make that much money. All right, let's look at the next problem. Okay, we just did the top one, so right now we're just focusing on the bottom one. Find the measure of each angle in the triangle to the left. We have 3 angles. They give us a hint that the sum is 180, so we should be able to add 1/10 x plus x minus 135 and set that equal to 180. Okay, so I'm going to add 135 to both sides. And on the right-hand side, that's going to give me 315. On the left, I'm left with, those are gone, I'm left with 1, 2, 3 x's, actually 2 and 1/10 x's. I'm going to write it for right this second as an improper a mixed number. I don't like mixed numbers, but that's how a lot of people think, so I'm going to leave it as 2 and 1/10 x for now, but I'm very quickly going to change that into an improper fraction. So it's 21 over 10x is equal to 315. So now if I multiply both sides by the denominator, I get 21x is equal to 3,150, and then I need to divide that by 21, and so that gives me x is 150. So this angle is 150 degrees. 1/10 of that is 15 degrees. And 150 minus 135 is also 15 degrees. The last thing we might want to do to check our answer is, do those add up to 180? And yes, they do. So those are the 3 answers here. Number 47. This is a lot like the football problem. William Shakespeare wrote 37 plays, including tragedies, comedies, and histories. He wrote the same number of tragedies and histories, but the number of comedies he wrote is 3 less than twice the number of tragedies. How many of each type of play did he write? Okay, so I'm going to say T is the number of tragedies. C is the number of comedies, and H is the number of histories. And so it's actually starting out exactly like the football problem. 37 is equal to T plus C plus H. That's all of them all together. So that's this first sentence. He wrote 37 plays, including tragedies, comedies, and histories. That's my equation for that sentence. The next sentence, he wrote the same number of tragedies and histories. So T is equal to H. But the number of comedies he wrote is 3 less than twice the number of tragedies. Okay, less than is the one time that we put it at the end of the expression instead of the beginning. So it's 3 less than twice the number of tragedies. So we're going to take twice the number of tragedies and subtract 3 for the number of comedies. Okay, now that I've got all that, I can put it together in one equation. So I have 37 is equal to tragedies plus comedies is 2t minus 3 plus histories is the same as tragedies. I want all of my variables to be the same letter. So I have t, t, and t. So now that I've done that, I can add my like terms. 1, 2, 3, 4. I have 4 t's here and a minus 3. So he wrote 10 tragedies. That means he also wrote 10 histories. And that means that the comedies is 20 minus 3, or 17 comedies. And once again, if we add those 3 up, they should add up to 37, which they do. Okay, this problem, we want to look at the graph. We have to look at the words and the graph. We also want to rely on some information from our past, and that is y equals mx plus b. Okay, how much water evaporates each day? If you look at the top, 5 down to 4.8, down to 4.6, down to 4.4, it is losing 0.2 inches every day. Part B, when will the height of the water drop below 2.5 inches? Okay, I'm going to go now to my y equals mx plus b. Y is going to be over here. My m is my rate of change. My rate of change here is it's going down 2 inches every day. My b is my starting point, and I start at 5 on my starting point. So question B asks, when will it drop below 2.5? Well, let's put 2.5 over on the left and then solve our equation. And this is another one where I'm using an equal sign, but then when we go back, we might put a less than or a greater than later. Okay, so I'm going to subtract my 5 from both sides. And in class, I've been talking about not using decimals. That's true. If the problem has fractions, leave it as fractions. But if the problem has decimals, let's leave it as decimals. Okay, so now I'm dividing by negative 0.2. So if I take a negative 2.5, I get x is equal to a positive 12.5. Okay, we probably should have defined our variables. Y was the height, right? That's what that 2.5 was how high it was. And x was the number of days. So this says it will take 12.5 days to get below 2.5 inches. If you wanted to say greater than or equal to, you could, because after that 12 and a half day, it's going to drop down. So you could say, well, can we have a half a day? You could. If you wanted to say 13, you could say that too, because it's below 2.5. Okay, if the pattern continued, what would be the height of the water after 30 days? Is this reasonable in the context of the problem? Okay, so for part C, I'm going to go back to our y equals mx plus b problem. And after 30 days, that's x is our number of days. And so if I plug in my 30 in for my number of days and I work this out, I get negative 1 inches. The question was, what will be the height of the water? -1 inches. Is this reasonable in the context of the problem? No, it's not reasonable because you can't have -1 inches. Unless the only thing would be is if your zero line for whatever reason was here in the middle and the day that you started it was up here and then the 1 was down here. But mostly no, that's not reasonable. Okay, last problem, number 49. What values of k make this equation an identity, which means infinite solutions? And then what values of k make this equation a contradiction, that is a no solution problem? Okay, so let's talk about identity first. Okay, an identity problem means that when you solve the problem, you get the same thing on both sides. That's what identity means. And infinite solutions means the same thing on both sides. So if I take this problem and I distribute it, then I get 2x minus 2k is equal to 2x plus 20. So a couple ways to look at it, but you see that the 2x is the same, and the only thing that we need is to get this minus 2k to look like a plus 20. Another way to say that same thing is, what if I subtract 2x from both sides? Then I'm left with a negative 2k is equal to 20. So k is -10. When k is -10, this problem is an identity problem, an infinite solution problem. Okay, a no solution problem would be when we get to the bottom and it doesn't make sense. It doesn't equal each other. Okay, if it doesn't equal each other, that's my clue to you. Let's say this doesn't equal instead. So I'm going to do the same exact thing. That is, I'm going to distribute, and then I'm going to subtract my 2x from both sides, and I'm going to divide by -2, and I get -10 again. It's the same exact problem, but this was a not equal to. So I can do that. I can just make an equation but make it not equals. So basically 10 makes it true. Anything that's not 10 is going to give it a no solution. Okay, let's try to think about that a little bit more before we close out this problem. Like, let's say 9. If I plugged in a 9, what would happen? Okay, if I plugged in a 9 here, I'd get 2x minus 18 is equal to 2x plus 20. Well, -18 does not equal 20. Okay, so 9 makes it a no solution. What if I pick something bigger, like 11? Okay, I'd get 2x minus 22 is equal to 2x plus 20, and the 2x's cross out, and I get a -22 is equal to -20, or positive 20, and that's not true, still a no solution. My answer is anytime that k is not 10, it is a no solution problem. Anytime k is -10, it is an infinite solution problem. I guess one last thing to consider is there ever just like a normal answer, like could x be 5 or anything like that? The answer is no, it couldn't. Because maybe if we start off by dividing ahead of time, then I get x minus k is equal to x plus 10. It has to be either a no solution or an infinite solution. There's no other way for that problem to work out. Okay, that is the end. Hopefully this video helped you figure out some word problems.